Okay, I'm going to be talking about the 12-petal rosé now. So this 12-petal rosé is a bit more complicated than the 3-petal rosé for a couple reasons I'm going to get into. But we're still going to follow the same process for calculating the equation of this. So starting off, is it sine or is it cosine? A sine function on an even numbered of petals rosé is actually not going to touch the polar axis or the pi over 2 axis. So those axes would fall right in between here. However, as you can see, it does not, which indicates that this is a cosine function. Cosine, where it falls on both of the axes. So we can plug that right in and get r equals a cosine b theta. Next step, what is a? Same as the previous function we looked at, the 3-petal rosé, a is just how far out the petals extend to. And these petals all extend to r equals 4. That line right, that circle right there, they're touching that. So the a value is 4. Now, the tricky part here is we don't know if this is negative or positive because they're the same. With even numbers of petals, the rosé could be negative or positive, and you can't tell the difference because it's symmetrical across both axes. So, unfortunately, we don't know, and we're just going to have to assume that it's positive. Now, what is b? b is not actually the number of petals this time. It's the number of petals divided by 2. That's just something interesting that occurs with these even number of petals for the rosé. So while I previously mentioned that with the sine function, the odd number of petals will flip between these, with an even number of petals, instead the unusual thing going on is that you have to divide by 2. So b is actually 6 in this instance because there's 12 petals if you count them up. So plugging in b gets us the final equation, r equals 4 cosine 6 theta. Anyway, that was slightly trickier than the previous one. Thank you.